Today's webinar is called Farming Practices, the Importance of Healthy Soils. There are billions of soil microorganisms in a teaspoon of healthy soil. Soil health is an essential component of agriculture, seeing as healthy soil is fundamental to growing a healthy crop. Dave McEachern will speak in depth about what soil health is and how he is building the health of his soil for future generations. Dave is very active in the agricultural community as a director with Grain Farmers of Ontario, Innovative Farmers Association of Ontario, and Farm and Food Care Ontario. Mike Buttenham will also be speaking in this webinar. Mike is the Sustainability and Environment Coordinator for Grain Farmers of Ontario. He's also an Envirothon alumni. Within his role at Grain Farmers of Ontario, he works with farmers and value chain partners to understand the complexity of environmental factors surrounding grain production and develop proactive win-win solutions. So without further ado, I'd like to welcome our speakers, Dave McEachern and Mike Buttenham. Whenever you guys are ready, you can go ahead and begin. Thank you.
All right. Good morning, everyone. I'm just going to get the slide to share, and I will start the presentation. So hopefully everyone can see the slide in front of me and hear me okay. Thanks, Diana, for the introduction. So as Diana mentioned, my name is Mike Buttenham, and I'm with the Grain Farmers of Ontario, and I'm going to introduce the topic of soil health and really why it is important to the farm. And Dave McEachern is a local London area farmer. He will take over and really talk about the specifics of what he's doing on his farm and why soil health is important. So just to introduce as well, I'm not sure how many of you know who or what the Grain Farmers of Ontario are. We're an organization that represents 28,000 farmers in the province of Ontario. And those farmers are growing on nearly 6 million acres across the province, from as far east as the Ottawa region and as far west down into the Windsor regions and even into central and northern Ontario as well. So our growers, 28,000, grow a mix of barley, corn, oats, soybeans, and wheat. And our interest as GFO is to represent our farmer members in a number of areas, including communications, research, market development, and government relations. And ideally, our goal as an organization is really to drive Ontario Grain to become a global leader. And that's something that is our vision as an organization. And I think some of the things that Dave is doing is really providing us an opportunity to really drive to become a global leader. So as I mentioned, what we grow cereal crops as well as other oil seed crops. So barley, for instance, is used in a number of products, cereals, dog foods, pet foods, you name it. Also malting and beer. We have corn as well that is grown. Corn's used in a variety of products, both food consumption as well as in bio industry, such as ethanol. Oats are used in a number of products for oatmeal, granola bars, that sort of thing. And soybean, the oil in soybean is used in a number of different products, from mayonnaise and dressings to crayons. And wheat obviously is a popular one that I think a lot of people recognize, and wheat's used in a lot of different products, mostly here in Ontario in cookies and crackers and those sorts of pastries. So that kind of sets the stage of what we're doing here in Ontario. Now, the main point of the presentation obviously is to talk about soil health and what soil is. So the slide here is, it isn't just dirt, and I think Dave will get into the detail that, you know, soil is not just dirt. And the fact of the matter is, as mentioned, that there are billions of soil organisms in a teaspoon of healthy soil. So that really reemphasizes that, you know, soil isn't just, it's just not something that you call dirt. You know, it is something that is quite of value because of obviously those billions of soil microorganisms that lead to, you know, growing a crop or in a forest or something of that nature. And further to that point, though, the United Nations have put together a study, and it really is showing that we're really degrading our soil across the planet. So they say that roughly a third of the Earth's soil is degraded in some form. So degradation means a number of things. Obviously, erosion, whether it be water, air, the soil is becoming eroded, and it is degrading the quality of the soil and the health of the soil. Soil, as mentioned, because there are billions of microorganisms, it is a complex thing. And as a result of that, it can take many, many years to form soil. It's not something that you can just create overnight. So a cool kind of stat that is out there is that it really takes close to 500 years, if not more, to form 2.5 centimeters of topsoil or an inch. So when you look at that on the ruler, 2.5 centimeters is not a lot. So it takes quite a lot of time to build your soil, but it takes quite few years to lose it. So I'll show a few slides in a bit to really show that. So the foundation of agriculture, I think when we look at agriculture, planting a crop, whether it be a corn plant or a wheat plant, the foundation of the success of that plant really is a result of functions of water, of sunlight, but as well as soil. And soil is really the foundation of everything we do in agriculture. And I think a lot of people maybe forget that at some points. So the basic properties of soil are, soil is a habitat for organisms of life. Soil really has the ability to store and retain and drain water. It also works as a way to cycle nutrients, to absorb, transform, and release nutrients that can be provided to a growing crop or a tree or something else that's growing. And really, soil is an anchor that really helps to anchor roots. Soil structure is really important to that root base in keeping that plant standing. So as I mentioned, soil is the foundation of agriculture, and I think as a result of this, it is an invaluable resource to farmers and to the agriculture industry. And I think it's one of our greatest assets. And the caveat to that is it's a great asset if it is managed properly. So today we really have a great understanding of the positive impacts that a healthy soil can play on farm. And I think Dave's going to really dive into the details of that and the positive impacts that a healthy soil do have on our environment. When we look at the wake of obviously a changing climate, soil is one thing that can really help us mitigate some of those impacts. And I think really we're starting to get into the period of time where research is investing in that soil space, and we're really better understanding the capabilities that a healthy soil can have, obviously on the crop, but also on our environment as it relates to water quality issues and as it relates to changing climate. And really with this new kind of understanding and greater understanding of the positive impacts, we really see a large group of people coming together to focus on soil health. And one of the interesting things that I thought I'd mention today is General Mills is a large company that's quite well known, but they're actually really heavily investing in soil health because whether it be the cereal that they produce through oats or granola bars, obviously those products are produced in a plant, but the reality is the oats that come from that product very much rely on healthy soil. So General Mills is very much leading the way as a large company in investing in soil health and very much to the point where they've actually hired an in-house agronomist, a soil scientist to really work on achieving positive outcomes. So I think it's a very telling sign when you have a large company such as General Mills that has hired a soil scientist on their behalf to work with farmers. So, this invaluable resource is something that a lot of people throughout the entire supply chain care about. Now, the two images ahead are what happens maybe when you don't protect your soil. So the left image that I have there with the snow cover is showing a slope that's been eroded during the non-growing season. And obviously the soil is bare, and when you have rainfall and and heavy amounts of rainfall, when there's no growing crop, there's nothing to anchor the soil, and as a result, the soil erosion is a reality. On the right-hand side, though, there is a growing crop in that picture, and the crop is still at a very early stage, so there isn't really that strong root base to hold the soil and to prevent it. So you can see both cases there is a loss of soil, and that's what happens when we don't protect the soil. But on the other side of that, there are certain instances of extreme rainfalls that are very difficult to manage. When you have a 1 in 100 year flood scenario, you're usually seeing high intense rainfalls, and sometimes we really, no matter what we do, have an ability to mitigate that. So I'm going to briefly touch on soil organic matter as well, and I think it's something that we've really talked about in agriculture for a long time, and Dave's going to provide some further information to this, but it is very important component of a farmer's soil, and it's important to a number of processes within the function of a soil. So nutrient cycling is a huge thing for crop production. Crops require nutrients in order to grow efficiently and effectively, and soil organic matter is a component of soil that really allows for that increased nutrient cycling. We also see that soil organic matter helps to improve the structure of soil, and the structure of soil is very important when you look at the porosity and the ability for water to not only drain through the soil when it rains, but also for the water to be retained within the soil. So soil organic matter does play a dual role in regards to water holding capacity and obviously the drainage and infiltration capacities. We also look at soil organic matter as pivotal to aeration. And when we look at compaction, that's a large thing that obviously can compact your soils and really create almost like a concrete structure where no water can flow through. So aeration is key, and I know Dave is going to touch on the compaction aspect as well. So he'll give some kind of real life examples to that. But again, soil organic matter really does help to support the biological activity of those billions of microorganisms as we identified in that teaspoon of soil, and soil organic matter really helps to support that. Now, there is an issue with soil organic matter that in some parts of Ontario we are seeing a decline. And according to Agriculture and Agri-Food Canada, there are close to 82% of Ontario farmland that is seeing some decreasing forms of soil organic matter. And I think the reality of this is that it's really much tougher to increase our soil organic matter than it is to lose. So similar to that example earlier is that it takes over 500 years to build close to 2.5 centimeters or an inch of soil. This is the same with soil organic matter. And the image there on your right is an example of soil erosion in the winter period. And the term that is used for this type of situation is called snert. So it's snowy dirt. And that's not a positive thing, because we are losing soil there, and we are losing our soil organic matter. Now, to take things further as well, the provincial government has shown strong interest in soil health, and as a result, there was a collective group that has come together to create Ontario's agriculture, soil health, and conservation strategy. And really the point of this initiative is to work on a long-term initiative to work collaboratively on soil health and really drive it as a key priority moving forward. And there's been kind of four main areas in which they are going to be examining over the years is soil management, soil data and mapping, soil evaluation and monitoring, and soil knowledge and innovation. So all of these four tie in very nicely. Soil knowledge and innovation is very much sharing the knowledge of soil health with farmers and agronomists. The data and mapping is a large thing because the latest soil maps in Ontario often are quite dated. So updating our soil maps and providing a more realistic scale will really allow us to better predict and to know what kind of soil that we are seeing within fields and the variability aspect. So I think this soil strategy is another emphasis that soil health is really being placed on from across sectors, including government. So tying in the concept of soil health, we've kind of done a brief overview of what soil is and some of the things that are being worked on. But a healthy soil can also be looked at as the quality of one's soil. But I think the caveat to that is there isn't really one specific variable that is looked at to define soil health. And soil health is really an all-encompassing approach that really looks at soil as a living organism. And we look at soil obviously as the physical properties of our sands or silts and our clay, and those are quite important obviously, but soil health really dives in further, and it really looks at the chemical and biological properties of soil and really viewing it as a living ecosystem. And as I mentioned, it is difficult to really determine what a healthy soil is in terms of the quantitative or qualitative approach, and that's where an area that definitely in research that we're lacking. But with that being said, there is work ongoing to look at soil health tests. So Grain Farmers of Ontario invests annually $1.8 million into research activities. And one of the research activities that we participate in was with a University of Guelph researcher by the name of Laura Van Aert. And Laura's project was really looking at the applicability of using the Haney soil test here in Ontario. Now, to provide some background, Rick Haney, who is a USDA associate, had developed a new soil health test in Texas. And this soil health test really evaluates the chemical and biological factors, as I mentioned, on soil health. And the idea was Laura would look at the applicability of this in Ontario, because Ontario is obviously a quite different soil system than is seen in Texas. There's obviously some differing factors that impact it. Now, as a result, there were inconclusive evidence from the research, but we're still trying to actively research these necessary parameters to evaluate soil health. And as a result, we're collaborating on a broader scale with the Soil Health Institute in the United States to really work on developing these parameters. But with that being said, we as Ontario and as Canada are quite far and wide in terms of leadership within the soil health area. And Dave McEachern's been involved in a number of initiatives here in Ontario, which he will explain on the whole soil health front. But the Soil Health Institute here is a U.S. initiative, and really the purpose of this initiative is to work towards soil health goals, to identify strategic priorities and identify the applicable scientific and industry stakeholders to advance the topic of soil health. So we know that there are gaps in research and adoption. We know that there needs to be more work done to really better understand soil health, especially on the chemical and the biological factors, and then also working on a better way to quantify and qualify these things. So this is quite a neat initiative, and there are a large number of researchers throughout North America that are involved in this. And I think there's going to be a lot of positive things coming out of this in years to come, as it works to benefit agriculture, but obviously the greater environment and society. Now, lastly, I'm just going to speak about the concept of regenerative ag, and this is the last slide before I'll turn it over to Dave. But there's kind of 5 main indicators or principles that we like to look at as a regenerative agriculture that is really working to regenerate soil and improve soil health. So the first is minimize soil disturbance. So obviously, minimizing the amount of tillage or disturbance to a soil. Crop diversity is another factor that's involved, and that's really crop rotation. So growing 3 or 4 or 5 different crops over the course of a cycle of a 5-year rotation can really help to regenerate. Another area is obviously keeping the soil covered. Keeping the soil covered is obvious, but it's an important thing to do. As those examples of the erosion earlier with the photos, I think it's important that keeping the soil covered to avoid certain situations where your soil might erode. Another thing is living roots. So living roots year round will obviously help to keep the soil stable and aggregate and allow for that improved soil structure. And the last point as well is very much a tough one in some situations, but integrating livestock. So integrating livestock back onto the landscape can really help to improve nutrient cycling. Obviously, manure helps to provide a feedstock, or it does provide, I guess, a feedstock for soil organisms and earthworms and bacteria and fungi. So these kind of 5 main principles together very much work strongly to regenerate and really work to improve soil health. And Dave's going to now highlight some of the specific things he's doing on his farm as it relates to some of these principles. So at that point, I'm going to stop sharing and I'm going to mute my mic, and Dave, take care.
All right, so hopefully everybody can hear me. And I will carry on where Mike left off there. So I'm going to talk about why soil health is important to us here at our farm. And I'll start off by telling you a little bit about who we are and where we farm. So we farm in Glencoe, Ontario, just north of Glencoe. It's in the southwestern part of the province between Lake Huron and Lake Erie. As we zoom in a little bit, you will be able to see all these red boxes basically represent the fields and farms that we operate. It's roughly 2,300 acres of grain cropland. I farm with my dad, my uncle, and myself. That's my son in front of me. My fiance is farming with us, so it's a family operation. It's a larger operation, but still family owned and family ran. And I'm going to talk a lot and more in depth about what Mike mentioned here about the regenerative agriculture cycle. So these five key items are really key. And I'm going to basically, my presentation will be on calling out each individual one and how we are trying to incorporate each one in our farm operation here. So I'm going to start off with the top one, and I left it up in the top corner of the screen there, minimizing soil disturbance. So in a conventional tillage system, which is what you see here on your screen, is the art of plowing. So this is the art of turning the soil upside down, essentially, flipping it over, burying the residue from the previous crop underneath, and it essentially exposes the underside of the soil to the atmosphere. This is a very, very old type of farming. This goes back 5,000, 6,000, 7,000 years to some of the first farming that happened as they turned the soil over to loosen it up. When we developed and settled farmland here in North America, a lot of it that was either prairie land or forested area was broke up with plows. Today, it's not a requirement to farm or to crop. We have not plowed on our farm since around 1990. So about 30 years, we have not plowed any of our soils. What you need to do after you turn the soil to the air is you need to break it down with further tillage equipment. That's what's shown here now. And any time that you run any tillage equipment through the soil, you are breaking up and destroying the populations of the microbiome that Mike talked about and referred to, of the living soil. If you could imagine, it would be like a bulldozer driving through the city that you live in, and anything that's in its way gets destroyed. The city would keep on living, but it wouldn't be very healthy after you did that. So what we do is in a no-till or minimum till system. We're trying as hard as we can to minimize any and all soil disturbance. This is a close-up picture of our corn planter. Starting from the right and looking towards the left, you can see these shiny silver round discs. That's essentially all the tillage that we do ahead of putting the seed in the ground. And the seed actually falls, top left-hand corner, you can see kind of a yellow color there, that's the seed box on our planter, and the seed drops from that box down in below those two wheels on the far left side of the picture. The only tillage that we're doing is a very small strip in front of where we're going to plant that seed, instead of full width tillage or tilling every square foot of the field. A little tiny bit of tillage for the seed bed is almost essential to get what we call good seed to soil contact. When you put a seed in the soil, you need to have it surrounded as well as you can and packed in with soil around it. If you were just to slice open the soil, drop a seed in and kind of push the slice back together, you end up with air spaces around the seed, and that doesn't allow for good germination. So this is our how we get around that. The next picture will show that corn planter actually driving through the field. I'm planting through cover crops, which we'll talk about in a few moments. But you can see there's green strips, which is not where the corn has been planted in this situation, or in this case. But in between, there's brown strips, and those brown strips are where the seed's just been placed. It's where those round tillage coulters have just kind of ran in a very narrow band ahead of the seed opener. And you can see a lot of kind of white-looking dead plant material on the surface. That dead plant material is from the previous crop. It's really important in our soil system. That feeds a lot of the macrobiology. That's night crawlers, worms, bugs of those sorts, and they essentially convert that, put it back down in the soil for other bacteria to break down even further. So that's what it looks like when we plant corn. It's not like what you might find in your garden of a nice tilled, fresh, bare soil. We try and keep it covered all the time. This would be how we plant most of our soybeans and most of the wheat on our farm. Again, this tool, it's a little bit different than the previous planter, but we literally pull into a field. This is planting winter wheat, so this is in the fall after soybeans have came off. That's what a soybean field would look like after harvest. We haven't worked any of the soil. We haven't tilled the crop residue under. We leave it on top and we plant right through it, and the wheat comes up. This is a picture of some soybeans coming up. You can see there's lots of plant material in between the rows. Those are from the previous corn crop. Mike talked about having a diverse crop rotation, and I'll talk just in the next slide, I believe, of the different crops we grow. But the plant material, the dead plant material that's left over after we harvest, absolutely gets left on top to help protect the soil. So as far as crop diversification goes, or crop rotation, we have three main crops on our farm: corn, which you see here, soybeans, and winter wheat. So that's a fairly typical rotation here in Ontario and in North America, for that matter, like the U.S. Corn Belt and southern Canada. There are other crops. Mike said we represent barley and oats growers as well. The corn, soybean, and wheat rotation are the three most common growing. They can be grown on many soil types and over quite a large geography is the other reason why. Some of the most southern geographies in Ontario don't grow as good cereals, be it barley and oats. We can't get as good a yield out of them just because of the hot, warm climate that we get in as we move further into the southern part of the province. But not all farmers rotate all three of those crops. Some will only rotate corn and soybeans. Some grow just soybeans and wheat. Some just grow soybeans. And so the more crop rotation you have, the better it is for the soil health and the life in the soil below. Basically, when you have different plant types, cereals are a grass. Corn is in the grass family. Soybeans are an oilseed. They're a legume, actually, a broadleaf plant in the legume family. So they have different rooting systems, and having different rooting systems allows for a good diversity of biology in the soil. Here's a snapshot of those same, at the beginning I showed you the red boxes of all the fields. This is a snapshot that shows the crop diversity. So the red boxes are fields that we had planted to winter wheat this past year. The blue boxes the blue fields were planted to soybeans, and the yellow ones were planted to corn. So as you can see, we have a pretty good colorful mix of those three crops. And we do rotate those around each field every year and plant a different crop on them. It is pretty rare that we plant soybeans back on soybean ground. As I said, pretty rare. The odd time we may have to do it because of, I mean, a good example is right now our winter wheat crop is coming out of the winter season, and some fields don't look very good and healthy. We may have to terminate and abandon the wheat crop because there's not much of a crop there. Those were soybean fields last year. Some of them may get planted to corn if we terminate the wheat crop, and some may get planted back to soybeans, depending on where we're at in rotation. But that's speaking on that second box of the circle up above of maximizing crop diversity. The other thing that we do that falls in between the next two boxes, maximizing crop diversity, keeping the soil covered, and a living root year round, is cover crops. And so adding cover crops increases the diversity of plants we have growing on our farm by tenfold probably, or maybe 20-fold. This is what I do with our wheat acres after we harvest wheat. So winter wheat, as I said, gets planted in September, October timeframe after soybeans have been harvested. It needs a cold winter period to actually germinate and create grain. And so then this time of year, the wheat fields are just greening up. If you are out in the countryside right now, driving around back and forth to school, you may see some fields greening up looking like they have grass growing in them, and that's winter wheat. That crop will mature in July, and we'll harvest that crop. Most winter wheat fields, they get harvested in July, sit bare and sit empty with nothing growing in them all the way till the following spring. To me, that's a huge opportunity to get a bunch more plant diversity in there and to feed the soil microbiome. Feed it with different roots, feed it with different plant materials. And so what I have here in this picture is about a 12 different species cover crop mix. The sunflowers are the obvious ones that everyone can see. They're very bright and beautiful. In between, though, there are plants such as oilseed radish. Mike mentioned compaction. Some of the great benefits to us growing cover crops and keeping the soil covered with a living plant year round is that those roots also can break up any compaction from the equipment that we drive across planting and harvesting. If soil is compacted, the roots are a great way to break up that compaction. Using a piece of tillage equipment, like I showed earlier, doesn't necessarily break up the compaction in a long-term way. It gives you a short-term gain, but you've broke down that soil structure by tilling it, and therefore makes it very prone to further compaction or future compaction. So some of the species that we grow as a cover crop, we use to battle compaction. We use them to feed the soil with nutrients. So the photosynthesis carbon cycle of capturing sunlight and energy from the sun, converting it into energy and carbon and putting it into the soil is a very basic and simple cycle that all of these plants do a good job of. Some of the legumes we include in here will actually fixate nitrogen from our atmosphere and put nitrogen into the soil. Nitrogen is one of the largest nutrient requirements that we have for both the wheat and the corn crop that we grow. And so instead of using commercial fertilizers that we have to buy and apply to the soil when we plant the seeds, if I can have living green plants capturing free nitrogen from the air, atmospheric nitrogen, and putting that into the soil to be stored for the next crop, that's a far better plan and deal for me. Not only me and my farm and the economic sustainability of it, but the environmental sustainability as well. And when we talk about sustainability, the third leg of sustainability being social, this field creates quite a buzz in my community and it gets people talking, and people are happy when they drive by and you have a nice bright field like that. So there's definitely some social benefit as well. This is kind of what the cover crop looks like. The picture on the right of me standing with my boots there. This is that same cover crop where the sunflowers were. This is the following February. So the ground is still very covered. a lot of the biomass and plant matter has broke down and already been converted back into the soil. But it's definitely covered. Not a lot of sunlight's going to get at this soil. Anytime that sunlight hits bare soil, it's killing the microbiome that's there in the soil, and we're also losing those important nutrients to the air, and we're also losing soil moisture. So those are some huge benefits of cover cropping. The picture on the left shows the corn crop pretty close to maturity, not quite ready to harvest, but pretty close. And I've actually had some cover crops seeded underneath my corn crop for the season, again, to help with water retention and nutrient cycling in the soil system. Mike shared some erosion pictures. This is some wind erosion. This isn't very far from where I farm. It is lighter soil where I took these pictures compared to the soil we farm, but sandy soils are extremely prone to blowing. You would never see this on this field if it was covered in green. And actually, I drove by this farm that I took this picture on just the other day, and it is absolutely green this spring. They did choose to put a cover crop on it, and it's essentially protecting that soil from blowing like it did. You can see this is almost like a snow drift that you'd see in the wintertime, but this is all sand that has drifted right out onto the road. Underneath all that sand is a green grass-covered ditch that's totally buried now in sand and soil from that farm. Just some more pictures of some erosion. This black in the ditch is really, really sad to see. That black is extremely rich, extremely nutrient-rich, high organic matter soil that is invaluable. It's priceless. And to see it laying in the ditch where you can't plant a crop in it is really sad. Sad to see that not all farm operators are following all the best management practices. And this is why groups like Grain Farmers of Ontario and farmers like myself go out and speak frequently, not only to groups like yourselves as students, but to other farmers, and advocate that they follow better management practices. And this is reasons why we see farms, like I just mentioned a minute ago, that are covered in green this spring instead of blowing soil in the air. This is what my sunflower cover crop field looks like in the middle of winter. Lots of plant material still there, keeping the soil intact. Roots and the activity in the soil don't go into hibernation like mammals do, essentially. They continue living and being active even in the off season. That's a really important item that a lot of farmers sometimes will miss out on. They'll think that there's no benefit over the winter months to having the soil covered because everything freezes. But underneath that soil surface, it is a whole web of living organisms. As I said, macro and microorganisms. I'll show a picture here in a second of all the different levels of organisms that are growing. But it focuses on that fourth item on the circle of keeping a living root in the soil year round. The other thing, when these plants do die, those roots don't just disappear the second the plant dies. Those roots now become a feedstock and food for all the soil microbiology. They also create waterways for water to infiltrate down through the soil when we're too wet. And they also create ways water will actually move upward in the soil when it's dry as well. And so those root lines and root tunnels are extremely important to the structure of the soil. This is the soil food web, and it shows the 5 levels of the 5 trophic levels. And at the end of the day, what this is doing is we're taking carbon, as I said, from the sun and converting it into energy and food. And that's the main purpose of what we do as a crop farmer. Is we're harvesting sunlight is what we're doing, capturing sunlight and energy and turning it into food products. But if you take away any part of this, the plants, the roots and shoots, if you take that away, you're giving up food for those next 2nd, 3rd, 4th trophic levels of bacteria, fungi, nematodes, etc. You can see them all there on the page. And they go right up to large animals and birds at the top level. But yeah, if you interrupt any of this, Imagine if these plants and roots and shoots and even the organic matter, the dead residue and waste is taken off the field or it's not left there. We basically eliminate or take away the population of all the other items on the page here. And that's where Mike mentioned about how it takes so many years to rebuild soil, but we can deplete it and degrade it in a matter of no time in a very short amount of time, if we take away the plants and don't have a living plant on the ground all the time. The fifth box there, and I'll wrap up with this, the fifth box is integrating livestock. Cover crops are a great way, as we just said, to feed the soil, keep it covered. There's a lot of benefits to that. And there's actually benefits to our commercial crops that I'm growing as well. I mentioned about nutrient cycling and capturing nitrogen out of the atmosphere and putting in the soil. If you can add the livestock component back in, it's kind of like putting it on steroids. The animals, it doesn't matter really what species, whether it's sheep, cattle, they will graze and forage on the cover crop. All those green plant materials are really healthy for the animals to be consuming and digesting. But the most important part is that they're converting that, much like we're converting carbon and energy from the sun into energy in the soil. These livestock, when they're allowed out on a cover crop to graze it, are taking all that plant energy and plant material, putting it through their digestive system and breaking it down even further in a different form. And that comes out, obviously, the other end and lands on the ground. And that feeds the organic, adds to organic matter, feeds the microbiome, again, a whole nother different type or different population of biology in the soil. And the actual act of the cattle's feet, the hooves, pushing plants down into the soil a little bit and stepping on some of that manure that they're creating, pushes that just ever so slightly into the soil profile that it increases how well that system works. I'm going to wrap it up there if there's time to have a few questions. That's my contact info, my email address, and my Twitter handle. If anybody has any questions anytime, you are more than welcome to shoot me a message, an email, or on Twitter, and I will get back to you as best to my knowledge as I can. I always invite anyone out to the farm. If you're out in the area and want to get your hands dirty or see, touch and feel and see what we're talking about out in the fields, we always have an open door policy here, and I'd be glad to host you. So I will I'll end there and stop sharing my screen and mute myself, and we'll allow the coordinator to come back on, and maybe we can tackle a few questions.
Hello. Thank you very much, David and Mike, for giving that informative presentation on soil health. At this point, we actually don't have any questions. So once again, I'd just like to thank everyone for listening. Thank you for doing this presentation. This is the very last webinar for the Ontario Envirothon of 2019. As David mentioned, if you guys do have any questions, you can always just contact him later on. But I think at this point, we're good to finish off the session. If anybody has any last minute questions, you can feel free to put them into the chat bar right now. But if not, then I think we're good to end the session.
I'll just mention a couple things. If any teachers are looking for a really interesting activity to do in their class, and it's hard to do on a webinar, so I chose not to put it in. But if you just do a simple internet search for the Earth as an apple, it's a really great way to illustrate the importance of our soil that we have for growing food on our planet. It essentially takes an apple and it starts off by cutting it into 4 quarters. The first 3 quarters represent the oceans and water that the Earth is covered in. The last quarter is the land portion. And it continues to break down that last quarter of land into smaller and smaller pieces, taking out things like deserts, swamps, and mountains, takes out cities, highways, soil that's too poor to grow anything on. And it basically ends you with about a 30-second of the apple that's left on the remaining land that we grow food on. And essentially at the end of that, you very carefully strip the apple peel from that 1/32 of an apple. And that little tiny piece of apple peel is somewhat representative of that top 6 to 10 inches of soil that we really only have to grow food on, because we don't, our food grows on our soils, and you can dig into our soils, but really the top, as I said, 6 to 10 inches is all that we have to work with. Anything below that is not capable of growing crops. Some of our plants do root down that deep or deeper, but if we were to strip away the top 6 to 10 inches and just try and grow seeds in that soil, it's not soil that's suitable to growing any crops. So that's a good little exercise to go through if you are looking for something to do interactive in a classroom.
Okay, thank you for sharing. So once again, just thank you very much for giving this very good presentation. And I think we're good to end the session now.
Sounds good. Thank you.
Okay, thank you, everyone.
Thanks very much.